So I want to show you how to calculate the amount of precipitate you'd expect to find if you cooled a saturated solution. So you have to think about the way this problem is set up. It says a saturated solution at 80 degrees Celsius cools to 30 degrees Celsius. So if we know, right, in general, the solubility goes down with temperature, that means some of the material that was in the solution will have to precipitate out of it in order to maintain a saturation level. Okay, it can't all stay in solution because as it cools, then it would be supersaturated. Eventually, that the extra material needs to precipitate out. So it says starting with 650 grams of solution at 80 degrees Celsius, calculate the ammonium chloride precipitate mass in grams. And then we're given two different solubilities. So if you're thinking about how you would do this problem, actually there's two parts that you have to do. The first part is you have to figure out how much solvent and how much solute you're dealing with in 650 grams at 80 degrees Celsius. So the first thing I'll do is say, well, I know that if it's 67 grams per 100 grams, right, I can calculate the mass of the solute in 650 grams using this ratio. So grams of solute, I'll start with what I'm given, 650.0 grams. And like we did before with the solubility limit in earlier problems, we set up a ratio. Let me do something really quick. This is grams of solution. And so I can calculate the grams of solute by saying 67.0 grams of solute for every 167 grams of solution. Okay. Again, solution mass would be 67. This is the solute, right? This is the solvent. And together, if you add them together, that gives you your solution mass. So this gives me the mass of solute that is in the solution at 80 degrees. And if you do the calculation, that comes out to 267.78 grams. I have three sig figs. I'm just carrying a couple to prevent rounding errors. And this is the solute. Okay, now, how much solvent is there? Well, if this is the mass of the solute, you can actually calculate the solvent without doing another proportion like this. What you can do is just subtract it from the solution mass. So solvent mass would be equal to 650 grams of solution minus 270.78 grams of the solute. And that gives me a solvent mass of 389.2 grams. Yeah, and because there's only sig figs to this point here, right, I only can keep it to the ones place. So now I have both the solute mass and the solvent mass at 80 degrees. And then for 30 degrees, I could calculate the mass of solute that would be in solution still because I have the mass of the solvent. Now, to do that, then again, 389.2 grams of solvent times, and then my solubility is 42.5 grams. Oops, some stuff left out of here. Grams of solute for every 100 grams of solvent. So 42.5 grams for every 100 grams of solvent. The water in this case, right? So that tells me that at 30 degrees I have 165.4 grams of solute in the solution still. So how much precipitates out? That's going to be the difference of what I started with in solution minus what I ended with in solution. So I'm going to go 260.78 grams of solute. This is at 80 degrees Celsius minus the 165.4 grams of solute at 30 degrees Celsius. And that tells me what's still in solution is 95 point, or what precipitates from solution is 95.36 grams. Now, in terms of sig figs, I'm still at this place here. So this is precipitate, what precipitates out of solution, grams of solute. So 95 grams, rounding to 2 sig figs there. Okay, so a little bit more of a tricky problem, more just to show you how you can do these kinds of calculations. To show you how the different units, you have to be really careful about knowing if you're talking about the solution mass or the solvent mass.